So the idea here is we're finding, and as we're looking towards in this next unit, finding derivatives analytically. Okay, so that's the whole purpose for this session and this unit. We found what we were talking about limits, and then we, as well in our last unit, we also transitioned from limits to how to find the derivative using the definition of the derivative. Remember, derivative is the idea of the slope of the tangent or the tangent slope is our main focus here. So the first function, and so a lot of what we're doing here is about recognizing functions. So different functions I'm going to use FTN for the future. Different functions require different rules. That is a biggie here. Now, the good news is we're going to learn these function by function before we start bringing them together. So I'll teach you a function like the power function, and then I'll show you a new function, but power function will still be interweaved within those, and a new one in the previous two, and we'll keep kind of cycling through so that we get to those. So the first thing we need to understand is what is a power function, and a power function is any function that can be written as f of x equals a constant, and that constant can be a fraction, times x to the n. And so these are the functions that we are going to be working with. A constant times x to the n. Now, something to note, n is a constant, can be a fraction, x is not in the denominator, and n can be, so n is a constant, can be a fraction as well. So the variable here is x. And the rule is, so some notations as well that we need to make sure we understand. So if the function f of x was a constant, we would say that f prime of x is equal to 0. Now, it's kind of weird doing this, so we use a little different notation here. We can say the same thing here in one part, and it says capital D with a little x. That means the derivative, all right, of a constant equals 0. So this is how we actually write the rule for a constant, all right? So this says the same thing as a part that I circled. The function is a constant. We're taking the derivative of that function, which is a constant, and that derivative is equal to 0. Now, I do want to show you why it works for anyone. And so the following is a proof. It is not something I will ask for you to do, but if you were, why is the derivative of a constant 0? All right. So why is the derivative of a constant 0? Well, if we use the definition of the derivative, then this is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, but f of x is just always going to be c. So this is the limit as h approaches 0 of c minus c all over h, because f of x plus h is still c, and f of x is still c because f of x is always c. which gives me the limit as h approaches 0 of 0 over h, which is the limit as h approaches 0 of 0, which is 0. So that is the reason why. It doesn't matter. If we were to do the definition of the derivative every single time for any constant, 5, 15, 28, negative 6, pi, e, square root of e, it doesn't matter what constant we choose. If we take it, if we utilize the definition of derivative every time and twice on Sunday, we would get 0 as the derivative. So for example, what's the derivative of 5? Anybody? What's the derivative of 5?
5.
Nope. Yes, good. And I want to hear someone that is correct in my private chat, but I want someone to share it out.
The answer is 0.
Yeah, 0. That's it. Boom, done. Another example. What's the derivative of pi? Yeah, a lot to cover today. I don't know if I'm going to have to squeeze it all in real fast at the end.
Also 0.
Also 0. What's the derivative of pi squared?
Don't tell me, 0.
It's 0. That's it. That's it. Here's a rule. It's a constant. Even a constant squared is still 0. A constant squared is still a constant. And if you think about it graphically, if you think about these graphically, a constant always looks like this. And the slope is always 0. So it makes sense if the derivative, which is just the slope of that tangent line, the slope of any line tangent to a horizontal line is the line itself, a horizontal line, which gives me a slope of 0. Next one, the derivative of a linear function, m times x. Okay, now you can think of this graphically. If you think about this in the same graph here, if this is y equals mx, what's the slope of the line tangent to that graph? If this is the equation y equals mx, what is the slope at any point along this graph?
0.
No.
What's out of the middle?
What is the slope of the line y equals mx? At any point, no matter where you go, what is the slope at any point along this?
Rise over run.
And so what is it? If the equation is y equals mx, what is the slope? If the equation of the line is y equals mx, what is the slope? I've given you the answer.
1.
I've given you the answer.
M.
It's m. The slope is m. Literally, right here, the slope is m, the slope is m, the slope is m. No matter where we go, over on the top part, no matter where I went, the slope was 0, the slope was 0, the slope was 0. So over here, remember we're doing these analytically. We're going to have the slope being m. Jateja, you have something to add? Or a question? Nope. Okay, just making sure. So for example, what's the derivative of 5x? Now, I could show you doing a definition of derivative and it works out the same way, but I feel knowing that there is a proof and it's through the definition of derivative, I just feel like we don't have enough time to do it remotely and to be beneficial for us. So what's the derivative of 5x? And yes, the answer, the answer is supposed to be obvious. Yeah, 5. What's the derivative of pi x?
Pi.
Pi. And what is the derivative of x times e squared?
X.
No.
The E square.
E squared. E squared is still a constant, but this is what we call a constant multiple. Or well, it's a, in all of these ones, so sorry, these are all linear. Okay, so these are all linear. Now, I told you that this is called the power rule. And what you should know is that a constant is technically a power function. Linear functions are technically power functions as well. Now it's time for the big one, the one that actually tells us both of these ones and is the name of today's lesson. The power rule of derivatives. And the power rule of the derivatives is this, and this is a rule that you need to memorize and should come out, should be no question about going forward in this class. The derivative of any function x to the n is n times x to the n minus 1. That's it. That's the whole power rule. Now, if we're dealing with a constant, you know, and it should be realized that constants is the same thing as y equals 0 times x to the 0. And so if you use this rule, you get, or sorry, that is the same thing as x to the 0. A constant is the same thing as x to the 0. So if you were to utilize the power rule, y prime, the derivative, I get 0 times x to the negative 1, which is just 0. And if I had x to the 1, then the derivative of x to the 1, that's a 1 and that's a prime, would be 1 times x to the 0, which would be 1. So these are just showing you that the rules also apply to the ones that we just covered right beforehand. But in reality, I like to have my students just memorize. Hey, if it's a constant, the derivative of that constant is 0. And if it's a linear function, the derivative of that linear function is just the slope in front of it, or whatever the slope is. If it's x and or x to the 1, however you want to write it, you get the same. Example. What is the derivative function? When I say the derivative, I'm talking about the derivative function. What is the derivative of x squared? Follow the rule. Right now, n is 2. It is written, it is a power function. What is the derivative of this function? X squared.
2 times x.
2.
Power of 2 minus 1.
Yep, which is? Which is? 1. 2 minus 1. Or we could just say 2x. That's 2 minus 1 is how we got that one right there. What is the derivative of x to the fifth?
Five x 1. Let's say equal 5x. Doesn't matter.
No.
By 1.
Ferrida, what is it?
5x to the fourth power.
To the fourth power.
Mm,
5 minus 1.
interesting.
Do another example. What is the derivative of x to the negative 3?
Negative 3x over 2.
Nope.
Mm.
Careful with your algebra.
Oh, yeah.
No, hold on. Darwin, I'm going to get somebody else.
Okay.
Can I get somebody else?
It's negative 4.
Negative 4. Be careful. A lot of people will think it's negative 2. Negative 3 minus 1 is negative 4. Now, it is okay to write this answer as negative 3 over x to the fourth. You should be comfortable seeing that these two are equivalent. All right, we got to make sure that these ones are equivalent because multiple choice problems. Example, next one. What is the derivative? And now we're improving our algebra skills, becoming more and more important. What is the derivative of 1 over x to the sixth? How do I do this problem? This one is different. This one requires an additional step. What do I do? What do I do here? Is this a power function? Yes or no? I'm not asking for the answer. I'm just asking for, is this a power function? Yes or no?
No.
No, it is not. This is not a power function. So we're going to rewrite this as the derivative of, because I still haven't taken the derivative. So let's make it into a power function using our algebra skills, using our advanced algebra skills. 1 over x to the sixth is the same as, I didn't hear anything. I just heard a bell.
Maybe x to the power of negative 6.
Very good. Now, that isn't the derivative, though. That's just how I rewrote the problem. So you got to understand the difference of rewriting to calculus friendly. Algebra. We need to understand the difference between algebra and calculus. So in this problem, we need to make it calculus friendly, which means we need to do some algebra to it. In doing so, now what is the derivative? You guys did the first one, the one before it, so it's almost exactly the same. What is the derivative of this one?
It's a negative 6x to the power of negative 7.
Perfect. And if you want to write this as negative 6 over x to the seventh, that's also good. Algebra. Let's do another algebra. What is the derivative of 1 over the fourth root of x? When I see this problem, what do I have to think? What do I have to tell myself?
It is x power.
Nope.
1/4.
You got to be careful.
Mm,
You got to be careful. It is the derivative of, because remember, we're not taking the derivative of. And taking what Darwin says, it is the derivative of 1 over x to the power of 1/4, which is the same as the derivative of algebra. The derivative of what? X to the
Negative 1/4.
-1/4. That's your algebra. So you need to turn this problem into this problem. And once you've done that, that's the calculus finally. Once you've done it, then the process is easy. Oh, the answer for this derivative? -1/4 x to the -5/4. Done. You should be able to subtract 1 from any number. If you're having a hard time subtracting -1 from -1/4, just take the denominator 4 and subtract it from the numerator -1. -1 minus 4 is -5. The denominator stays the same. It's just a quick algebra trick of subtracting 1 from any number, any fraction. So algebra manipulation. And I would like you to leave the answer like that. If you want to leave the answer as -1/4x to the 5/4, I'm happy with that. I don't like using fourth roots and so forth. That's good. Or if you want to, technically 1/4 fourth root of x to the 5th. But I mean, it gets ugly. You'll never see a multiple choice answer written like this. You might see it written as -1/4x to the 5/4. You might see it like that. Now, let's just combine the rules. Well, sorry, you have one more rule. You have technically 2 more rules. The next one is called the constant multiple. And it sounds complicated, but it's not. The constant multiple rule says the following. The derivative of any constant k, let's call it k for a purpose it's different than c, times a function is simply the constant times the derivative of the function. The truth of the reality is I need to write down this formula for you, but you would do it naturally. For example, what is the derivative? And let me actually write this problem in a different notations for you because I need to start getting, it's the same questions. Y is equal to 3x to the 5th. Find y prime. What is y prime? In other words, there's that 3 in front. You don't do anything for the 3. The biggest mistake I get people that do, they'll think, oh, the derivative of 3, that's a constant. So the derivative of 3 is 0. No, it's not. That's if it was a constant on its own, if it was a constant term, if it was a constant function. 3 is a constant multiple. It's attached to the x to the 5th. So the derivative of 3 is not 0. You're looking for the derivative of 3x squared as in a whole, which means it's a power function, and you're going to apply the power rule, which means the 5 comes down, which gives you what?
5
Nope.
times 3.
Yeah, you're right. You are right. And you know what? I'll write it that way. I'll write it down this one. Typically, you want to just give me like what the answer is, but it is lecture notes. You're right. I should write it like this. Times x to the 4. Yeah. So typically we would say y prime equals 15 x to the 4th, and boom, in one step you're done like that. The 5 gets multiplied by the 3. All right. So the constants, they just stay in front. Sum and difference rule. The sum and difference rule just states that the derivative of any function plus or minus any other function is simply equal to the derivative of that first function plus or minus the derivative of the second function. Another one that sounds way more difficult than what it actually looks like. You would naturally do it. If you understand what we're doing in terms of these rules so far, you would naturally do this rule. For example, y is equal to 2x squared minus 3x plus 5. Find dy dx. And I'm trying to show you these new notations because that just means the derivative of x. That just means y prime. They all mean this. This is the last notation for derivatives that we typically use, dy dx. It just means a derivative again. Okay? So dy dx is, and we just take the derivative. How many terms do we have in my function? How many terms? 3. So how many derivatives am I going to take?
That's 3, they say.
Yeah, I'm going to take 3. So I'm going to take 3 derivatives. So what are my 3 derivatives?
The first one, 2x over 2.
No.
Power 2.
No.
The first one would be, wait, do you want the full answer?
Yeah. Yeah, give me the full answer, what I would get.
4x to the 1.
Then the derivative of the second one? It's a linear function.
That's 3x.
No.
No, 3. Negative 3. Only negative 3.
Minus 3. Good. Plus.
5.
No. It's a constant. It's a constant.
0.
Plus 0. And typically when we write this answer, you typically would go directly to 4x minus 3. You don't have to show the plus 0 part. 5 is a constant, so the derivative of 5 is 0. The final thing I want to show you for today is the derivative at a point. We'll get into this a lot more in the Friday's lesson. But there is a homework problem on this because I want to just show you one really quickly. Let's do, for example, f of x equals 2x squared minus 3x plus 5. Same one as above, right? And this problem says, find f prime of 4. Okay? You want to find f prime of 4. If you want to find f prime of 4, well, we could have used the definition of derivative, and that's what you're going to have to do on your test, right? However, when you want to find f prime of 4, you first need to find f prime of x, and then you can find f prime of 4. All right, so first find a derivative function, and then you plug in 4. So if that was the case, I'd find f prime of x, and what is f prime of x again on this problem? What is f prime of x?
F prime of 4.
What is f prime of x? It's just a different notation. It's the same thing as me asking you for dy dx. What's the derivative of this function? What's the derivative? Yeah, 4x minus what?
3.
4x minus 3, boom. And so if I want to find f prime of 4, I simply plug in. I plug in.
4.
I plug in 4. And so my answer is 13. It's 9:50. Don't worry, we have a lot more practice coming on Friday. The Delta Math, these are things that are not tested on you for tomorrow. This is something that, it takes practice. It's the first time that you're seeing this. So these rules might seem a little bit weird and odd. It's like a different way of doing algebra, but it's not algebra. We're talking about slopes here. In the rules, this is the power rule. There's no matter where you look up, the power rule is basically the power rule everywhere. Um, I'll see you tomorrow for the test or for checking in if you're doing the take home. Um, like I said, this homework is